Hey, welcome to the Explainer. Every time you stream a movie, hop on a video call, or just use an app, you're plugging into this massive physical machine, the data center. It's the powerful, totally unseen heart of our digital world. But what's the real cost of just building the thing?
Okay, so we talk a lot about the incredible amount of electricity these places eat up just to power servers and keep everything from melting. And look, that's true. It's a huge piece of their environmental footprint. But that's only the operational story, right? That's what happens when it's running. There's this whole other side to their impact that we hardly ever see.
So what if I told you that a massive chunk of a data center's carbon footprint is already locked in? It's baked right into its structure, the steel, the concrete, the racks, before a single server even gets powered up. That's exactly what we're digging into today.
So to get our heads around that, we've got to talk about this really important idea. It all comes down to something called embodied carbon.
Think of it like this. It's the total carbon price tag that comes with a material before it even gets to the construction site. So it's not about the electricity bill once the data center is up and running. Nope. It's all the carbon that was puffed into the atmosphere just to make the building blocks in the first place, from digging iron ore out of a mountain for steel to firing up a kiln for cement.
Okay, so how big of a deal are we talking about here? Is this a big number? Well, according to the World Green Building Council, embodied carbon from the construction industry worldwide accounts for a pretty staggering 11% of all global carbon emissions. That's huge. And this is one of the toughest nuts to crack when it comes to decarbonization. And you better believe data centers are a big part of that.
So you see, if we really want green data centers, we can't just look at the power plug. We've got to go right back to the beginning, to the foundation, and that means we have to tackle the two heaviest hitters when it comes to materials: concrete and steel.
I mean, these materials are the literal backbone of a data center. They provide all the strength you need to hold up millions and millions of dollars of super sensitive gear. But they're also incredibly carbon intensive to make. The good news, though, the big players in the industry are now totally zeroed in on this problem.
You've got tech giants like Amazon Web Services, for example, really leading the charge here with this kind of clear four-part game plan. First off, just be smarter with the design, right? Use less of the stuff to begin with. Then, they're in the lab actively testing out new, greener concrete recipes. At the same time, they're pushing their suppliers to make cleaner steel. And finally, they're putting money into those future next-gen technologies that might one day make cement not just neutral, but carbon negative.
All right, let's talk about steel for a second, because how you make it is a really big deal. You basically have two paths you can go down. The old school way, the basic oxygen furnace, or BOF, well, it starts with raw iron ore and is super heavy on fossil fuels. But then you have the alternative, an electric arc furnace, or EAF, and it's a completely different animal. It's electric, and its main ingredient is recycled scrap steel.
And this is what people are talking about when they say circular economy. Instead of digging more stuff out of the ground, the EAF process takes our old cars, our old washing machines, all that construction debris, and just melts it down into brand new high-quality steel. Just making that one choice to use recycled material, it has this huge ripple effect.
So, how big of a ripple are we talking? Let's put some numbers to it. Just by switching from that old-school BOF steel to the recycled EAF steel, you can slash the embodied carbon by up to half. But wait, it gets even better. If you power that electric furnace with renewables, like wind or solar, you can crush the embodied carbon by as much as 80%. I mean, that is a game-changing reduction.
Okay, so we've covered the big stuff, the skeleton of the building. Now let's walk inside the data hall itself and look at something a little smaller, but just as important, the thousands and thousands of server racks that hold all the computers.
I saw this quote on a Reddit forum, and it just perfectly captures a real-world problem engineers face. This person had a client who was building something near the ocean, and they were worried about the salty, humid air literally rusting out their steel racks. It's a great point. Sometimes the standard way of doing things just doesn't cut it, and it forces you to look for better alternatives.
So, for years, server racks have been made from cold-rolled steel. And for good reason, right? It's super strong. But it's also really heavy, it can rust, and it conducts electricity, which isn't always great. Aluminum is lighter and doesn't rust as easily, but it's not quite as strong. And that brings us to this really interesting third option: fiberglass reinforced plastic, or FRP.
And this is where FRP starts to look like a real game changer. It's super strong for how light it is, which makes it way easier to install. It's basically corrosion-proof, perfect for our friend on Reddit building by the beach. But for me, the coolest properties are these last two.
It doesn't conduct electricity, which is a huge safety win, and it's a thermal insulator, which can actually help with managing all the heat in the data hall.
Okay, so we've gone from the giant steel beams all the way down to the individual server racks. But to really get sustainability right, you have to zoom back out and look at the whole picture, the entire life of these materials from the second they're created to the moment they're thrown away, or hopefully reused. And there's actually a formal way to do this. It's called a life cycle assessment, or LCA for short. It's a method that stops you from accidentally solving one problem just to create a bigger one somewhere else. Basically, it makes you ask all the tough questions about a material's entire journey. Where'd it come from? How is it made? How's it used? And maybe most importantly, what happens to it when it's done? And steel is the perfect poster child for this. Its life isn't a one-way street to the dump, it's a circle. Steel can be recycled over and over and over again without losing quality. Old products become the raw material for new ones using that EAF process we talked about. This is that whole cradle-to-cradle idea in action.
And when you start thinking in these big, full life cycle terms, it leads to some really mind-bending innovations. We've been talking about making things less bad, but what if a data center could actually create something good? What if its number one waste product, heat, could be turned into its number one need, power?
Well, believe it or not, this is now actually possible. It all starts right at the source, at the chip itself. Instead of just blowing air across it, advanced liquid cooling systems pull intense heat directly off the processors. That heat is so powerful it boils a special coolant, turning it into vapor. That pressurized vapor then flows and spins a tiny turbine, and that turbine generates clean electricity that gets fed right back into the data center.
I mean, it's just this brilliant self-powering loop. Suddenly, waste heat isn't a problem you have to get rid of, it becomes one of your most valuable resources. This isn't just about being a little more efficient, it's about completely rethinking what a data center is, seeing it as its own integrated energy system. And that really brings us to the final big picture question. We started this whole thing by talking about data centers as these massive energy hogs, but with smarter materials, cradle-to-cradle design, and wild innovations like turning heat into power, what if all that could change? Could the engines of our digital world one day power not just themselves, but our homes and our cities too? That's the kind of truly sustainable future that's actually being built right now.